Okay, so we have a short vodcast today because this is really just wrapping up our balancing equations to get you ready for part 2 and 3 of the worksheet so that you can go ahead and get started on balancing some equations of your own. Now, I want to give you a bit of a shortcut tip that is something that I used when I was first learning chemistry to keep everything kind of straight in my head. There are 5 basic C's, and if you can remember these 5 basic C's to easy equation balancing, it'll make your life considerably easier. Think of this as kind of a short annotated version of the rules that we went over in the last podcast. Now, before we go over the practice that I gave you guys as homework from the last podcast, I want to go ahead and go over these with you because I will be referring to these when I go over that problem. And the 5 C's to easy equation balancing begins with count, okay? The first thing you need to do is count the atoms on both sides of the equation, your reactants and your products. So you count on both sides, and each side is separate, of course. So you count your atoms first. Then you compare. So you compare your reactants and your products. You should have the same number of each element of the atom on the left as you do on the right. So you need the same reactants and products to be in those counts that you took. Okay, so the first 2 C's, count and compare. Now the next step involves 2 C's in the same step, which is to change your coefficients. And then you change your coefficients. Remember, you are not changing subscripts or superscripts. This isn't C's and S's. This is just C's. You change coefficients. Those are the big numbers in front of each one of your elements or formula or molecular formulas. So you change your coefficients, and you do that until your atom count on both sides is equal. So you can change those coefficients to whatever you need in order to make those element numbers work. Now, do remember that those coefficients apply to everything that comes after them. And so, for example, if you put 2 in front of H2O, you are multiplying all of those atoms by 2. So you're going to end up with 4 H's and 2 O's, for example. Okay, so you change your coefficients until you end up with equal amounts on both sides. And then finally, you check. You check to make sure that all of the atoms are accounted for, because remember the law of conservation of mass, which says that we cannot create or destroy matter. So no atom can go unaccounted for. So our last step, of course, is to check and make sure that all of the atoms are accounted for. And if we need to, if something isn't right, we have an oxygen here that isn't showing up on the other side, then we need to go back to step 1 and count our atoms on both sides, compare, change the coefficients, and check again. So repeat with me a couple of times so that you can remember the 5 C's to easy equation balancing. Count, compare, change coefficients, and check. And then repeat as necessary. So I'm gonna show you with the equation that I left you with at the end of the last podcast. We're going to take a look at that word problem, how we set up the skeleton equation, and then how we balance the equation. Okay. So the example that I left you guys with after the last podcast was silver 1 nitrate reacts with copper metal to produce copper 2 nitrate and solid silver. So we're going to take a look at how we would go about setting up the skeleton equation first. So we have, of course, silver that has a charge of 1, because the silver 1 nitrate means that the silver has a charge of +1. And nitrate has a charge of -1. So how many of each of these would we need? Well, 1 silver would combine with 1 nitrate, would bond with 1 nitrate, so that we could form silver nitrate. AgNO3 is our silver nitrate. Of course, it reacts with copper metal. So metals are, with one exception of mercury, our metals are going to be found in the solid state. So our copper metal to produce copper 2 nitrate and solid silver. So the end result here, copper, remember we have copper, it has a charge of 2. How do we know that it has a charge of 2? Because it's in that transition metal area. Well, we know it because it actually tells us in the problem that that copper has a +2 charge. And of course the nitrate has a -1 charge, and in order to get the right number of, to get those charges to balance out, to get the right number of nitrates, we need to make sure that our nitrates balance our copper charge, and if we have +2 over here, we need to have a -2 over here. The only way to get that is to multiply this whole nitrate by 2. So of course our copper nitrate should look like this. It should have CuNO3 times 2. So we have copper 2 nitrate and solid silver. So of course we need our silver, we had our silver over here, so we need our silver over here, and it's going to be a solid, so we should put the S in parentheses over on the right. So the first thing we do, remember our 5 C's, our count, compare, change coefficients, and check. So our first step, of course, is to count. So we need to count how many of each atom we have. Now, remember that I am not going to break up our NO3 simply because our NO3 is a polyatomic. It's going to stay together. It's going to stick together. So that nitrogen is not going to separate from these oxygens. So we count all of our silver, our nitrate, and our copper. So on the left we have 1, 1, and 1. And on the right in our products we have 1, 2, and 1. Now this is a problem because these aren't balanced. Somewhere we added a nitrate, and we can't produce a nitrate out of thin air to show up in our products. And so it has to be on the reactant side. This is where we count. Okay, we've counted. Then we compare. The silvers were good. The nitrates were not good. The coppers were good. So we need to take a look at how we can get one more nitrate over on this side. So of course we can't just add in another nitrate because it's not in the problem. So what we do is we add a coefficient of 2 to the silver nitrate. So we have 2 silver nitrate, and this is going to change our number of atoms, and so we need to make sure that we go ahead and change those. Now we have 2 silver and 2 nitrate. So we've counted again. Okay, we've changed our coefficients, and then we check. And we check and say, okay, now we have 2 silver over here and 1 silver over here. Well, we compared and found that we're not equal on both sides. So what we can do is we can come over here to silver, and we add a 2 coefficient in front of the silver, which will of course change the number of silver atoms on the right hand side to 2. So now we have 2 silver and 2 silver. So 2 nitrates and 2 nitrates, and 2 copper and 1 copper and 1 copper. So we now have a balanced equation. We counted, we compared, we changed our coefficients, and we checked. We repeated that twice because we had to change 2 of the coefficients. We had to change a 2 here and a 2 here. But this gives us a balanced equation. Okay. So now I'm going to show you a more complex example, and this is, it looks a little terrifying, but the steps remain the same. You count, you compare, you change your coefficients, and you check your results. So here we do it step by step, and remember that your hydroxides are going to stick together. You're going to stick your phosphates together as well. So let's take a look. There is a helpful hint that I wanted to include in here, where if you have a hydroxide ion on one side of the equation and a water on the other, you can simply rewrite the water as HOH. So it's actually hydrogen hydroxide. So while it might look like we broke this hydroxide apart, right, this hydroxide from our zinc hydroxide, where it may look like we broke it apart, we really didn't. It's still intact. It's just got a hydrogen attached to it now. Okay? So what we can do is just write our H2O as HOH, and that'll make it a little bit simpler. So here on the left side, we have zinc, we have hydroxide, we have hydrogen, and we have phosphate. Okay? And of course, we kept our P and PO4 together because that is a phosphate polyatomic. This is where it comes in very handy if you were one of the few people who'd memorized the polyatomics at the beginning of the school year, when I told you that it would make things easier on you later if you did. For those of you who listened, you're going to find that this is much simpler for you because you recognize a polyatomic when you see it. If you can't easily recognize your polyatomics, then this might be a little more challenging for you. So we're going to go ahead and do our first step, which is to count our atoms. Okay, we have 1 zinc, 2 hydroxides, 3 hydrogens, and 1 phosphate on your reactant side. So now we're going to count the atoms and elements on your product side. So you go ahead and count all the way down. We have 3 zincs, we have 1 hydroxide, we have 1 hydrogen, and we have 2 phosphates. So once we're done with the counting of our atoms, now our job is to compare. So we compare 1 zinc over here to 3 zincs over here. Of course, that's not going to work for us, and so after comparing, we want to change our coefficients. So of course, we need to change the coefficient of this zinc to 3 so that we have 3 zincs on this side. So after comparing, we need to put 3 zincs over there. And this is going to change the number of zincs we have, but it's also going to change the number of hydroxides we have. So that brings us to 6 hydroxides because we have 2, and then we're going to multiply the whole thing by 3. So 2 times 3 gives us 6 hydroxides. So our changing of the coefficient has changed our count on the reactant side. So now we compare our second polyatomic ion here, the second ion here. We have hydroxide on the left, we have 6 of those, and hydroxides on the right, we only have 1. So that would be the next coefficient that we would need to change. So we need to put 6 over here to even out this 6, and that would make this then 6 hydroxides. Okay. So now our zincs are balanced and our hydroxides are balanced. But remember that if we put 6 in front of this HOH, it's also going to change the number of hydrogens. So don't forget to go back and repeat the count the atoms step each time. So we need to count our total atoms. Now we have 3 zincs, 6 hydroxides, 6 hydrogens, and 2 phosphates. So we go ahead and take our next step to take a look at our hydrogens. And of course, we need more hydrogens on this side because now we have 6 here and 3 here. So we put this 2 coefficient, and this will turn this number of hydrogens into 6. So we add those and make sure that you are counting all of your atoms. Of course, adding that 2 in front of the phosphoric acid, that phosphate acid, then we would also choose this 2. We would change this number of phosphates to 2. Okay, so this means that we actually have now a balanced equation. We check the last step, 3, 6, 6, 2, 3, 6, 6, 2. Our coefficients are 3, 2, 1, and 6. Okay, so that is how you can take a very complicated looking example, run it through the same 3 count, compare, change coefficients, and checklist, and how you can use Miss Carr's Easy 5C method to balance any equation, hard or simple. All right. And go ahead and try this with your worksheet parts 2 and 3 so that you can be ready to do this on the quiz. Make sure to mark any ones that you're having problems with, or make any note or change any notes that you have to ask questions, and we'll see you in class.